Thank you, Arushi, for answering my questions.
No need, sir. It's okay.
Yeah, and host, so you can greet Arushi for today's session, and you permit her to start the presentation.
Thank you, sir. A very good evening to one and all present here. Our special guest, Arushi, our coordinator, Nirmal sir, and all the amazing ones who have joined this program. We heartily welcome you all in this program. And next, I hand over the session to Anamika. Anamika?
Thank you, Stinmay. So good evening, all of you. GKG Club welcomes you here. So today we are having Arushi Sharma. She is a second year MCA student from IGDTUW, Delhi. She is selected for ACM India Winter School NLP, Flutter developer, front end developer, UI UX designer. So now I welcome you, ma'am, to start your presentation on introduction to natural language processing. So welcome, Arushi.
Thank you so much, Chinmay and Anamika, for such a uh, great welcoming, warm welcoming. So, yeah. So, Nimal sir, can I start the session or I'll wait for some minutes?
Yeah, you can start the session. It's 6:10 now.
Okay, okay, sir. Okay, now I'm presenting my slides. Just, yeah. If my screen is visible, I guess.
Yeah, it is visible.
Okay, okay. So let's get started. In today's session, we are going to have the introduction of natural language process. So basically, I'll get you familiar with it because in my bachelor's, I didn't know about it. I've never even heard about it. So recently, I've developed an interest in NLP, and I did an internship with ACM Winter School India, which I guess Anamika have just told you all. So yeah, let's get started. So just basic about myself. I guess you all know now by now. And moving forward, then we just let's talk about the content of the today's session. That what we are going to have in this session. First, we'll talk about what is NLP. Then we'll talk about its applications. Then we'll talk about what text data and its concepts. Then we'll see the key techniques related to NLP and how these techniques can implement on real data set. Okay. One thing important, guys, if you get any any difficulty to understand any topic or any uh, doubt in your mind, just interrupt me then and there. Do not wait me to get over the slide or get uh, uh, after the session. Just interrupt me, okay? So yeah, that is how it's gonna work. So yeah, let's talk about the applications of natural language process. First, we have search engine. Now, search engine is the software in which user can write any text query to search the information available on the internet, right? The second application of NLP we have Google Translate. It's basically a machine translation system in which one language is translated to another. Say English is translated to Russian or French like that. Then we have sorry. Then we have conversational systems, example chat box, voice agents, which interacts with human and responds to their queries and questions. You can heard about Alexa or Siri also. That is your conversational systems only. Moving forward, we have next that is news categorization, in which any given news is classified into defined class, such as politics, entertainment. So this is news categorization. Moving forward, we have spelling corrections. It is a software that is included in most popular document editors right now. The screenshot I've used here is a screenshot of a Grammarly software, which is basically used for you to whenever you type any incorrect word, it help you to correct it. It help you to make your sentence grammarly correct. So this is all the applications of NLP. Moving forward, let's just we will see what is data set and its type. So talking about data set, it is an ordered collection of data. First, let's just see what the data set is and its specific types. After that, we will develop the understanding of NLP so that it will easier for you to understand what exactly the natural language process is. So the data set is an ordered collection of data. So while handling the data set can be bunch of tables, scheme, and other objects. Okay, so there are basically two forms of data set. The first form is structured data set, and the second form is unstructured data set. Talking about structured data set having fixed number of dimensions. That is fixed number of keys, values, or fixed number of rows, columns. Okay, now they contain information in well organized form. It is present in tabular format. Relation database such as SQL. You've come across SQL in your bachelor, I guess. Okay, so key value pairs related to SQL. So that is the example of structured data set. And the screenshot I've used here is the example of structured data set in which every column is indicating some defined class. That employee ID is having some employer IDs. Then we have another column called name, which contains the name of employees. Then we have, so it's basically have a fixed dimension, fixed number of rows and columns, well structured, well organized. So that is a structured data set. Moving forward, we have unstructured data set. In contrast to structured data set, the other form of the data set is unstructured, which lacks in any particular structure and do not have any dimension. So this means that unstructured data can take any form. Okay. So different types of unstructured data set can be your audio, your video, your images and text. Because why I'm saying that images, text, videos are unstructured? Because when videos and images are processed by machine, they convert it into long text containing bits and bytes of text, which we human cannot understand easily. So I've given an example. I've taken this picture from Google and I tried my machine to get a text document of this picture. This is what I get in the right side. I don't think any one of you can understand this document because that is unstructured data set. So we will gonna work on unstructured data set. So now you have developed the understanding of data set. Let's move forward. What exactly the examples of text data set? The most prominent example of text dataset can be your conversations in which you do messages, email, chats, and all. And the second one is your social media in which you tweet, post, comments like that. Okay. So data set is essential in any manner, any written form of a natural language, for example, English or French, you can say, it takes any form of natural language. So it consists of a characters or words arranged together in a meaningful and a formal manner, which means the text data is driven by a grammar rules and defined structure. So now that uh, we have discussed about text data, let's just understand what is NLP, what is natural language process. So it is a branch of data science which deals with deriving useful information from the text data. Like I've given a text data, I'm applying NLP on it, and I'm getting some information, important information and insights from that text data on which I've applied my natural language process. So this is the layman definition of NLP for you to get understand bit more clearer. Okay, so it contains several different techniques and process which are used to analyze, understand, and utilize the text data for solving business needs. Often we come across the term applied NLP, which means the use of NLP for deriving and developing applications or system in which there exists a human interaction with machine. So that is what applied NLP is. So this is the definition that I get from internet. You might get across it if you search the definition of NLP. So it says the field of study that focuses on the interaction between human language and computers. Okay. If you look closely into the Venn diagram, it the NLP sits in the interaction of computer science, artificial intelligence, and computational linguistics. Now, computation linguistic is the study of applications of computer in processing and analyzing language, as automatic machine translation or text analysis, or you can say it's in simple language. Computer linguistics can be your human language, in which we we generally interact with computer to understand, to make it understand to do some task. If I want my laptop to do addition of two numbers, how can I give instruction to my computer so that computer understands it and give me the sum of the two number in resultant? So that is your computational linguistics, in which computer understands your language. Okay. So yeah, that was the basic concepts of NLP. Okay. Before we go ahead, any student is having any doubt from the previous start, you can anytime interrupt me. Okay. So now we come across the techniques related to NLP. So let me just give you a glimpse of what we are going to do in upcoming slides. The first we have corpus, tokens, and engrams. Then we come across what is tokenization. Then we come across the concept of normalization, which includes its two types. The first one is stemming, and the second one is lemmatization. Okay. So then we come across the part of the speech tagging, which is basically in the concept of grammar of sentences. If I want to know the grammar of some sentence, then I need to know what is part of speech tagging. Then I come across the dependency grammar. Okay. So that is the content of basically upcoming slides. Let's just talk about what is corpus, tokens, and engrams. So talking about corpus is nothing but a collection of text documents. So whenever I'll be using my term corpus, just think I'm talking about the term document. You can, in NLP linguistic language, you use corpus instead of calling text document. Okay. So corpus comprises of documents, documents comprises of paragraphs, paragraphs comprises of sentences, and sentences comprises of tokens. Now we come across another word which is called tokens, which means it's the smaller units of a text. And that smaller unit of a text can be your word, can be your phrase, can be your n-grams. Now, talking about n-grams, what we have, it's a combination of n words or characters together. For example, I've written a sentence here which says my favorite color is red. So if I talk about unigram, unigram is nothing but taking token one at a time. If I'm defining n is equal to 1, which is number of words I'm taking consideration to be 1, then it will be called unigram, and the unigram gives me the token of the given sentence would be my favorite color is red. So that is a tokens of unigram, which is having only one word. Talking about bigrams, in which I take two words at a time. So bigrams would convert it into my favorite color. Color is red. Okay. Then we come across trigrams, which basically taking three words at a time. So it can be defined as, so the tokens will get converted after applying trigrams on a sentence, and it will give me the result as my favorite color. Favorite color is red. Now, one thing is important in n-grams, that uh, you cannot break the sequence of the word. Like I cannot have a bigram which contains my color. You cannot do that. The computer cannot allow you to do that. So remember that n-grams is only a combination of a words together in a sequence. So whether you are doing unigram, bigram, trigram, or 4 gram, there is also 5 gram, 6 gram, so many grams. So you never break the sequence. That is the characteristics of n-gram. Now moving forward, uh, we have now tokenization. Now, what is tokenization? It is the process of splitting a text object into a smaller units. Now, text object is nothing but, you can say, corpus or a document. Any line having, uh, big sentences or number of lines, you can say text object to be consideration into that. And splitting of that sentence into a smaller unit, which is called tokens, that is the process of tokenization. Now, our smaller units can be your words, can be your numbers, can be your symbols, can be your n-grams and characters. So, in most commonly used process of tokenization is white space tokenization, or you can say unigram tokenization, uh, in which I split my sentence based on a white space. For example, if I given a sentence, I went to New York for higher study. So when I will be split it into following tokens, when I applied my tokenization process into it, that is I went to, now all the words, all the character in the sentence will be converted into unigram and based on the white space. If there is a white space in a sentence, it will split from there. Now, one thing noticeable is in here is that New York didn't get split. Why? Because New York is not having any white space in between. That is why it's not get splitted. So, talking about another process of tokenization we have is regular expression tokenization, in which a regular expression pattern is used to get the tokens. For example, I'm having a sentence football, comma, cricket, golf, tennis. Okay, this is the sentence which is having which containing multiple delimiters. That delimiters is a comma. I'm using the line. Now see, we can split the text by passing the code that is written here. That is re.split. This is the Python code that we use to split our sentence using regular expression tokenization. Tokenization can be performed at the sentence level or at the word level or at even the character level. So the tokens I get after splitting the sentence is football, cricket, golf, tennis. Okay, so this is my token that I get after applying regular expression tokenizer process. So this is about tokenization. Moving forward, we have normalization. Normalization is a process, okay. In the field of, I can say in the field of linguistic or NLP, I use word morpheme. There is a word called morpheme, which is which can be defined as the base form of the word. Okay, so a token is generally made up of two components. The first is morpheme, which means the base form of your word, and the second term is inflection forms, which are essentially your prefixes and suffixes. For example, in example I've given anti-nationalist. Now the base form of the word, you can see directly that national is your morpheme, and anti and is your prefix and suffix, so it will come under inflection form. So normalization is the process of converting a token into its base form, that is morpheme. It helps in reducing the data dimensionality and text cleaning. Okay, I'm going to define text cleaning in my upcoming slide. And why we are studying normalization, tokenization, all these concepts, you'll get clear later on. So let's just understand the concept first. There is two types of normalization. The first is stemming and the second one is lemmatization. Okay, so yeah, talking about stemming, it is an elementary rule-based process of removal of inflection forms from a token. If my token contains inflection forms, which is my prefixes and suffixes from the token, I'm gonna use my normalization technique, which is called stemming, to remove that inflection form, and the output will be my stem of the word. For example, the words I've given here is laughing, laughed, laughs, laugh. Now all these words will be converted into laugh after applying stemming process onto it. And the inflection forms in all these words is ing in laughing, ed in laughed, s in laughed, and there is no inflection forms in laugh. So all these words get converted into the morpheme, which is stem of the word, or which is called the base of the word. Okay. Now, one thing important, that stemming is not a good normalization technique, because sometimes stemming can produce the words which are not present in the dictionary. For example, take an example that I've given, that is that his teams are not winning. When I applying stemming process into this sentence, the token that I get is "Hi team are not win." Now notice that the keyword "win," you see WINN win, is not a regular word, and "hi" changes the context of entire sentence. So that is why we do not use stemming process usually. We use another process of normalization, which is lemmatization. So talking about lemmatization is the systematic step-by-step process for reducing a token to its lemma. Okay, it makes the use of vocabulary, word structure, part of speech tags, and grammar relation. The output of lemmatization is the root word called lemma. Here we called the root word to be lemma. Okay. So for example, am, are, is will be converted to be, and running, ran, run, rans will be converted to run. Okay. So since it's a systematic process, while performing lemmatization, one can specify the part of speech tag for the desired term, and lemmatization will only be performed if a given word has a proper speech of tag. I'm saying lemmatization can only be performed on those words which are having proper speech of tag. If a word is does not associated with any speech of a tag, then we cannot apply lemmatization onto that. For example, if I want to lemmatize the word running as a verb, it will get converted to run. But if I try to lemmatize the same word running as a noun, it won't get converted into run. Okay. So moving forward, now we will talk about syntax and structural properties related to text. Okay. We have come across part of the speech tag, which basically are the property of a words which define their main context, their functionality, and usage in the sentence. Okay. So some of the commonly used part of a speech tags are nouns, which defines any object and entity, verbs which define some actions, adjectives and adverbs which can define, modifiers, injectifiers. So every sentence get post tag, which is part of a speech tags. For example, in a sentence that is David has purchased a new laptop from Apple Store. Now, in this sentence, every word is associated with their part of speech tag, which defines their functions in the case. For example, David has NNP tag, which means it's a proper noun. Has and purchase belongs to verb, indicating that they are actions. Laptop and Apple Store are the nouns. New is the adjective. Okay. So part of a speech tag are defined by the relation of word with the other word in the sentence. Okay. Machine learning modules or rule-based modules are applied to obtain the part of a speech tag. So that is how part of a speech tag works. Moving forward, this is the most commonly used part of a speech tag. Notations are provided by Penn Treberg part of a speech tag, which a total of a 48, I guess, 48 part of a speech tag, according to their usage. Okay, so we have the Penn Treberg has given the tag, then its description and the example. You can see this after the session. Now, part of a speech tag has number of applications. Okay, like part of a speech tag applied on pronouns. It can give verb. It can be a adverb, adjective. So it has many applications. Talking about their usage, it used in text cleaning. Now, I'll give you the example. What is text cleaning right here? Text cleaning is basically what that if I have a text document with me and I want to extract some information through that text, what I'll do, I'll first start with cleaning my text. That like I want my document to be free of any exclamation sign, any comma, any any at the rate or anything, and I want to get the information of the names present in my text. So this is called text cleaning, that I'm cleaning my text to get some important information through it. So part of a speech tag is really useful into that. Then the second usage of it is feature engineering task. It's similar to text cleaning with some engineering task you involve through the text. Now, the third usage is word sense disambiguation. Now, let's understand what is this. For example, I've given the sentence one which says, please book my flight for New York. And the second sentence I have is, I like to read a book on New York. Now, in both these sentences, the keyword book is used, but in sentence one, it is used as verb. And in sentence 2, it is used as a noun. So that is word sense disambiguation. That part of a speech tag is makes user or makes uh, machine to understand that is which sentence is acting on which part of speech. Like both book is the same word, but in first sentence I use it as a verb, and in second sentence I use it as a noun. So that is how part of a speech helps in distinguish the both of the sentence. Okay. So moving forward, let's just talk about the grammar of a sentence. And the first type of the grammar is constituency grammar. Any word, any phrase, any group of word can be termed as constituents, and constituency grammar can be defined that it is used to organize any sentence into constituents using their property. And okay, so these properties are generally driven by the power of a speech tags, noun phrases, verb phrases. For example, a constituency grammar can be defined that any sentence can be organized into three phrases. Okay, I get any question? I've heard any one of you have,
Yes, ma'am, I have a question.
yeah.
Ma'am, these NLPs are used for that computers or machines used to observe our language, right?
by using these NLP. So, ma'am, Google Assistants, which are already in our phone, they also use NLP for the processing. I mean, they observe our language and give us the relatable answer as well. So, for that also, NLP is used. I mean, like, I'm just learning about this thing for the very first time. So, I'm trying to connect it with something I'm familiar to. So,
Yeah, you
am I connecting right that for that purpose also, I mean, like Google Assistant, there is some processor in our phone which used to convert and break the sentence in particular, like bigrams and trigrams, and by that process, Google Assistant used to observe our sentences comprehension, whatever we are speaking to it, uh, like that it works.
exactly. You are absolutely right, Soumya. You really asked a great question. That Google Assistant is basically, if you want, like today what we are doing, we just today we are short of time, so we just ask Google to open this, to open that. So Google heard it and do some tokenization technique into that, and then normalization to get our words divided, splitting into tokens, and give me result. So that is the concept of NLP only. That is what we are doing. I've discussed the applications in the earlier. Maybe I didn't use the Google translator translation. So that is, you're correct. That is the part of NLP only.
Ma'am, I have another question. While giving some instruction or while doing some programming for our computer or particular for our any of the machine, how can we find out that in how many grams we have to divide a sentence to properly to enable our machine or computer to properly observe that particular sentence or that kind of stuff? How can we analyze that in how much n grams we have to divide our sentences? For example, you have told us that the color is my favorite color is red. So in bigrams we are dividing my favorite color, the color is red. So how we can justify what we have to exactly do to process our command?
Okay. Okay. So, Soumya, the basic understanding of it, that you need to, distinguish that whether I use bigram in it, whether I use trigram or foregram, based on the task you perform. For example, in a text, if I want to know the name uh, the text has used, like I want to extract all the names the text has used, and the name is can be bigram like Arushi Sharma, or can be your trigram like your name, Soumya Jyoti Singh, right? So based on the task what you are doing, you told the computer to do similar gram. Okay, if your name can be, anybody name can be of 3 grams. I don't think anybody name can be more than of 4 grams. So what you'll do the 4 grams tokenization in the NLP, and the computer will generated all the 4 gram till 4 grams of the names that you want to get as an output. So it will give you a bigram, it will give you a trigram, it will give you a 4 gram, since we have used all this. Okay, so based on the task, you split the tokens.
So, ma'am, for the processing of our linguistic commands, whatever we are giving to the computer or machine, we have to.
Yeah, I think you've muted yourself by mistake. Can you say that again, Soumya? Am I audible?
Yes, you are
Yeah,
audible. I
you are
think there
audible.
is a
Soumya, you
network
can
issue.
speak now.
Excuse me, am I audible?
Yeah, yeah, Soumya, you're
Yes,
audible.
yes, you are audible.
For processing of our linguistic command, whatever we are giving to the machine or computer, we also have to particulate it with that we are using book as a verb, as a pronoun, or I mean book as a verb or book as a main subject. We also have to instruct the computer while processing of such NLPs.
No, no, no. That is not your task to do. That is the task of machine learning and rule-based practice that I've just discussed. It basically, what machine learning and rule-based practice do, it will give you a part of a speech tag of a particular sentence. So machine learning is different thing, different from NLP. So the task is given to the machine learning to do such type of like book can be your verb, can be your noun. So that is not your job to tell the machine. It's job that machine learning or rule based practice can do. Okay, I've given in my slide also. Here you can see. Mm. Yeah, here it is. I've written that machine learning and rule based process is is the process that is used to give me the part of a speech tag of a given sentence. Okay, so that is the technique we are going to have to develop to know our part of a speech tag. So, did you get, Soumya?
Yes, ma'am. I'm getting that, and now I'm able to connect it properly. Actually,
Okay, I'm glad to know that. Anybody is having any doubt, or I'll just move forward. Okay, so I think there's no doubt. I'm assuming that I should move forward. Yeah. So there we were. We were we were in our constituency grammar. So I was saying that these constituency grammar can take different values and according can generate different sentences. For example, I have taken no sorry. First of all, let's just understand the property of it. So a constituency grammar can be defined that any sentence can be organized into three constituents. The first one is subject, the second one is context, and the third one is object. So it can generate different sentences according to its uh, according to its part of speech tag, noun phrases, verb phrases. For example, I have given a three sentences here. The first one is the cats are running in the park. The dogs are barking happily. They are eating since morning. These three sentences I have given, and I have to apply constituency grammar into it using speech of a tag, which is the property of constituency grammar. So what it will do? It will convert the first constituents to be a subject, which stores the value of the cats, the dogs, they. The second, we have context of a sentence, which stores the value of our running, our barking, our eating. Then third, we have object of it, which stores in the park happily since in the morning. Okay. Another view to look into constituency grammar is to define their grammar in terms of their part of speech tag. See, a grammar structure containing a determinant noun or adjective, verb, preposition, determinant, which corresponding to the sentence, the barks are barking in the park. Okay, so that is another view to look into constituency grammar. The different type of grammar we have is another type of grammar we have is dependency grammar, which states that the words of a sentence are dependent upon other words in the sentence. Okay, for example, in the last sentence, I've just said barking dog was mentioned. So the dog was modified by barking as the dependency adjective modifier exists between the two. Okay, you cannot use barking alone. This barking is a modifier adjective which you used related to dog. So that is our dependency grammar work, that one sentence is dependent on the other sentence. Now, the okay, the it is used to organize the words of a sentence according to the dependencies. All the words are directly and indirectly linked to the root of the root using links. Now, there is only one root in the sentence, and every other word is directly or indirectly linked to it. These dependency represents the relationship among the words in a sentence. I'm giving you an example for you to better understand. I've give the sentence I've given here is I prefer the morning flight through Denver. This is my sentence. Now the root of the sentence will be my prefer. Okay, because every other sentence is depend on prefer. If I do not use prefer, then there is no meaning of the sentence. That is why I prefer is my root, because I get to know what is we preferring, who is we preferring, and how it is going to prefer. So this is our dependency tree. Having prefer is the root word, and every other word in the tree is dependent indirectly or directly on the root word, such as direct object, then this is our direct object, then direct subject, then modifier, etc. Okay, so these relationship defines their roles and functions of each word in the sentence and how multiple words are connected together. Now see this dependency grammar table. I've given it says that clause argument relation between each words and its description, like NSUBJ is described to be nominal subject, DOBJ is direct object. It is not your part to understand this table, it is the machine part to understand that table. I'm just giving you the knowledge of how dependency grammar works. That every word in a sentence is indirectly or directly depend on the root of the word. That is how dependency grammar works. So, yeah. Now let's just talk about the use cases of dependency grammar. I believe this is our last slide. So just basically these all are the algorithms. So you need to listen really carefully to understand these algorithms. The first algorithm which uses the dependency grammar. Now we talk about whatever we have discussed from the previous slides. We talked about tokenization. We talked about normalization. It's two techniques. How do we do text cleaning? Now, uh, dependency grammar can be used in name entity recognition. It's a task, or you can say it's an algorithm which helps you to easily identify the key elements in the text or corpus. Like if you want to extract the name of the people, if you want to extract the places given in the text, brands, monetary values, and more. So that is the task of name entity recognition, in which uh, I want to get the name of the people. What I'll do, I'll make my document into the text cleaning session, in which I first divide my document into n-grams. Then my n-grams will produce, uh, will go further for normalization, in which I basically be removing all the, delimiters, all the exclamation, at the rate, useless things from my text, which I do not need. Because if my algorithm works on these kinds of things, my time complexity will become more. So that is why I do not want my text document to be not free of these uh, exclamation signs or these unwanted things. So then we apply part of a speech tag, which is the part, which is basically the part of machine language or rule based practice, which is they're gonna do that part of a speech tag. Then we come across the dependency grammar, and after applying dependency grammar, I get to extract the name of the people, places, brands, or anything you want to extract from that text document. Okay, so second algorithm which uses the dependency grammar is a question answering system. So they can be used to understand the relation and structural aspect of it. Like you have used Quora, right? Quora is basically a site which you use for question and answering system. Like you put question and some other people read that question and give you an answer. So that is how Quora is working. It's basically a question answering system which just which just make you understand the relational and structural aspect of it. Now, the third we have is co-reference resolution, in which the task is to map the pronouns to the respective noun phrases. Okay, this is the task, and what we actually extract from co-reference resolution. Co-reference resolution is different thing. So the task of it is to just map the pronouns on the respective noun phrases so that I can get some information, so that I can know what I need to do in my algorithm to make machine understand, think of it all, and give me the output of it. Then we have a text summarization problem. This is the algorithm that I've done in my ACM winter school. I've come across the text summarization in which I did the main task. Okay, let me just give you the introduction of what exactly text summarization is. Have you come across the novels or any fiction or non-fiction books? So basically, how you if I have interest in reading novels, what I'll do, I'll just go to the back page of it and read the summary of the novel it contains. If I get interest, I'll buy the novel. I'll buy the novel. So the process of text summarization is to produce summary of a big text. Like I, it's it's difficult for human who doesn't know the book, and if he wants to get the summary of it, what he gonna do? He gonna read as a normal human being. He gonna read all the pages and get the summary out of thinking from his mind. Now, uh, what my task is to make machine learn how to produce a summary of a given text. I apply text cleaning on that, and text cleaning is basically the same thing. I remove unwanted um unwanted things from my text like exclamation, all these. I do not need that. I do not need any names. I just want summary. I'll I'll apply part of speech tag. I'll apply dependency grammar into that. Then I'll applying all these concepts to get the summary of my text. That is how the text summarization problems work. I'm going to show you the code of the text summarization of it. Uh, it's hardly understandable. You don't get the code, but if you come across later after the session, or you develop any interest of it, you can have the code with you, so you can apply, you can understand later very well. Then we have text classification problems. It's the same thing, but in a different classification, that I do not want the summary, I want some classification of it. I want what this text containing related to business needs. Like I do not want to know if that text involves some story, if that text involves some places. I just want to know what is the business needs of this text. So that is how you work with text classification problems. So yeah, that is all about the introduction of natural language process. Now, if you any case go through NLP, developed interest, you can, and have any doubt or info, want to know more about it, you can always mail me and message me in LinkedIn. I've given my GitHub repository also, like where you can get your code of n grams and something like that. Let me show you. Yeah. Here's my repository. You can. I've given you the link in the PPT. I'll upload the PPT in my NLP repository also. So you can always fork it and download it so that any changes you do won't reflect in mine. So let me show you the models of n-grams in which we split our text into bigrams, diagrams, or any gram. So I'm importing, here I'm taking, it's a code in Python first of all, and NLTK is nothing but a platform used to building a Python programs that work within human language for addressing NLP. So if you get NLTK library Python, you might not get in Java. There may be some other libraries in Java or C or any other. In Python, we use NLTK. Now from NLTK, I'm importing word tokenization, because if I if I only use import NLTK, it will import everything present in the NLTK library, which I do not want. I just want my text to divide it into bigrams or diagrams. So I do not want. So I'm from NLTK. I'm importing word tokenization. Then from NLTK util, which is also a library present in NLTK only, I'm importing n grams from it. Then from collections, which is also a different library present in the NLTK only, import counter. Now, full form of NLTK is Natural Language Toolkit. Okay. Here I've given my text. Text can be your any text. You can have your French text. You can have your Spanish text. Any text you can give here. And then I'm using an attribute token. What it is doing? It is taking word tokenization and the parameter I've provided the text. Whatever the text I've defined here, it will automatically become here because I'm defining parameter. That's the basic concept of Python. So talking about bigram, I'm getting my bigram by this line that I am using my ngrams function. Ngrams is my function which taking two parameters. The first one is token and the second word is how many tokens do you want it. If you're using bigrams, then it would be 2. If you're using trigrams, it would be 3. If you're using 4 grams, it would be 4, 5 grams, 5, 6 grams, and so on. Okay. So to calculate the sequence of the sentence of a sequence of words. Now I'm printing counter. Counter is another function which is used to print the consecutive tokens from the text. So this will print my bigrams, this will print my trigrams, 4 grams, and 5 grams. That is about the uh, models of n-grams. Talking about text summarization, I think it's a Jupyter notebook, so it will, I think it'll take some time. I don't know why GitHub has some issues. Okay, it's open. So first I'm just importing, this is NumPy is another library for my for my NLP. NumPy is a library which is used in NLP. Okay, then I have import stop words. Stop words is basically when you get some comma, when you get some exclamation sign in the text, you are downloading that stop word. Okay, then it's another punct. Okay, now from Google, I've just imported a file from Google Colab. Like you have just upload it in your text. Like I want to apply text. I want to get the text summary of COVID text. Okay, so that is how I'm going to upload it in my Jupyter notebook. Now Jupyter notebook is a really good for doing NLP program. If you do in your VS Code or some other software, it might give you some error. I did that. I might get some error and I get really confused of it. So Jupyter Notebook is really good with NLP. So I am tokenizing my sentence. This is the code you want, like you won't get easily understand, but this is how I'm doing my text summarization. You'll get through it once. Okay, don't go through it once. Just build your concept of uh, NLP. Then you'll get to know more about its concept. At the end of developing now, you'll only get text summarization problem more better. So that is, yeah, that is, I'm going to upload the PPT here also so you can get the PPT. So yeah, any doubt from any one of you? That's about the session. I guess you guys understand or
Anyone having
Arushi,
any
your
questions,
presentation
you
was
can
so
ask.
good. And
yeah. Okay, there are questions in the chats. Okay. Mind give an example of each use case from real life scenario. Okay. You want Kartikeya, you want examples on which exactly use cases on which topic you want the real life scenario when it comes to these algorithms. Okay, I do not understand the question in which can you unmute yourself and ask me if that's possible, Kartikeya?
Yeah, Arushi, can you hear me?
Yeah, I can hear you.
Okay, can you like go to the slide?
Which part?
Um, it's like the second last, maybe.
Okay, yeah, right.
Yeah, that's what I think you were like on the second one, and then you started like explaining the scenario. So I think we are good. But on the first one, you didn't like tell us the example. So if that possible, makes sense.
Okay, named entity recognition, you want example of that, right?
Yeah.
Named entity recognition, you can take a real life scenario of, for example, you have a text, you have a PDF of any book in your laptop. What do, you just type Control and F. Okay, you type these two keywords and write down the word of like any topic you want to get through it. Any, you do not want to scroll the whole PDF. What you do, you just type Control and F from your keyboard and type the word that you want to get, that you are looking for. So that is the work of NLP, which is called name entity recognition, in which you get the output of whatever output you want it to be. Like, you, from a text, you want the names of the text given. Like in a text document, if I have given so many names, like there may be Kartike, there may be Arushi, there may be, and so many names. So you want to extract the names only. You do not go through a whole PDF. So named entity recognition is going to help you in that scenario, in which you want to extract some information from the text based on what you actually want. Whether you want the name of a places given in the text, whether you want the monetary values of it given in the text, whether you want the name of people. So that is how the name entity recognition works in real scenario. Yeah, you can give.
Okay, perfect. One more thing, can you like go to the GitHub profile of yours? You were like showing some code on Jupyter.
Sure. On which file?
Yeah, I think it's text summarization. Yeah, I'm not sure. This should be the one though. Okay, so basically my question was, how are we like splitting the sentences? Is it like coming from the NLTK library, or because we are not using any splitter or like RE for regex? So, did you get my question?
Yeah, I get your
All
question.
right, perfect.
We are splitting our sentences using tokenization, like I've defined in the process of tokenization. There is a two process, right? So we are doing in here. I'm not, basically it's a text summarization. So I do not want to exactly split my sentences. That is why I'm not uh, doing splitting sentences here. But if you want to go on the other task, there might be the procedure of splitting. In text summarization, if I want to extract the summary of a text, I really do not want to split my sentences. You understand? Like, it's not required. So I'm not doing any splitting of the sentences here.
But in the beginning, I think you said that we need to like convert, we need to like have a sentence in order to like make a branch out of it and create the grammar and then the tree. So we should have a sentence of each construction instead of like having the entire paragraph.
Yeah, based on the task you have given, you do that. If you do not want to do the normalization of the text, you won't do it, because I don't think that getting summary of a word is related to splitting into its parts.
I'm not like focused upon the like what this program is doing. I'm just mainly concerned how we split the sentence. When it goes to like real life scenarios, is it like we split it by the end of the line and using full stop, or what is it like?
I've the splitting, you can split the sentence by two methods. The first one is stemming and the second one is lemmatization. Based on what exactly you want, like, wait, I'll show you. Yeah, I've written the code there. Just get, yeah. Here you can see it's a splitting of a text into a smaller unit. Like, if you want your text to get splitted based on a white space, you can use you're going to use the white space tokenization. And if you want your sentence to get split on full stop, or get split on comma, get split on semicolon. So you will use this line, re split, and then I'm using slash in place of this comma if I am going to split my sentence based on comma. And if I want to split my sentence based on hyphen, I'm going to use hyphen instead using comma. Are you getting, Karthikeyan?
Yeah, I do. Thank you so much.
Not a problem. Any person having any doubts?
No.
Okay.